let's take a look at when we have two vectors that are in two different dimensions. So if we were to represent vector A looks like 3 units in the positive x direction, okay? So I'm going to try to replicate that by measuring it down. It's like 2.3. So here's my vector A, right? Here's my vector A. So my vector A is 3 units in the positive x direction. And my vector B happens to be 4 units, right? 1, 2, 3, 4 units. All right, so here's my vector B, which is 4y hat. When I add these two up, you have to add their, right? So your direction as well. So here's my A. I will place the tail of my B onto tip of A. So here is my B vector. Now, of course, this is not exactly. And my resultant vector is from my tail of A to tip of B. So that's my resultant vector C. What direction do I give here? I can't say x hat because it's not on the x-axis. I can't say y hat, it's not on the y-axis. How do I give direction? Well, you give direction by giving the angle that this vector, resultant vector C, is pointing. Okay? So for direction, right, theta must be given. Now the theta goes from 0 degrees to 360 degrees, right? Therefore, when you have 0 degrees and then you go counterclockwise, right, counterclockwise to these 4 quadrants. So how do I calculate the magnitude? Well, this looks like a right triangle because x and y are perpendicular to one another. So it creates a right triangle. So we can simply say c squared is equal to, right? I guess you could say a squared plus b squared. Right? So to calculate the magnitude, right, we can say c squared is equal to 3 squared plus 4 squared. So that is equal to 9 plus 16. That's my c squared. So c is equal to square root of 25, which is 5. So this magnitude of c is 5 centimeters long, or 5 units long. But the angle here, theta, and that's important, can be calculated by saying tan inverse of, right, b over a, or the opposite over adjacent. Okay, so my theta is equal to tan inverse of b, which is 4, over a, which is 3, and that comes out to approximately 53 degrees. So, how do I write my resultant vector now? It is written as following. It is written as 5 centimeters comma, theta is equal to 53 degrees. That is known as a polar form, okay? Polar form. So this tells me the location of this resultant is going to be, if I go 53 degrees and then walk that way 5 centimeters, that's exactly where the location. It gives me exact one unique location. Okay? If I just say 5 centimeters, I have no idea which way 5 centimeters I have to walk, you know? But when I give you 53 degrees, then you know exactly which direction you should walk 5 centimeters. So now you have one unique position. All right, so little background of, I guess we should all be familiar with this, but I'll still do some just in case when some people are saying, I'm kind of rusty on this, Mr. Kim. That's fine. So we'll do a little review of quadrants, okay? Let's say I have my resultant vector in like first quadrant, like so, okay? Then the first quadrant has positive x and positive y, okay? This angle here is theta, okay? This theta is between, right, 0 and 90 degrees. So theta has to be measured counterclockwise, okay? Let's say I have my resultant vector in second quadrant here, okay? Then at second quadrant, your angle is measured from the positive x-axis to where the vector is. This is my theta from here all the way over. At second quadrant, I have negative x and positive y. And theta is between 90 degrees and 180 degrees. This angle right here is known as beta, which is the reference angle, and it will be a negative angle. Okay? And then I should draw another one because this is going to get messy if I keep drawing everything on a one axis. So let's say I have a resultant vector in the third quadrant right here. So at the third quadrant, I have negative x and negative y, okay? The theta, which is measured from the positive x-axis all the way around counterclockwise to this, is my theta, okay? This theta is between 180 and 270 degrees. Okay? This angle here is my beta, which is the reference angle. Now, for the fourth quadrant, let's say I have a vector going like this in the fourth quadrant. So the fourth quadrant, this is my angle theta for the fourth quadrant. Okay, maybe I should really write this little subscripts down so that this is 3, this is 1, and this is 2. Right. So my quadrant 4, I have positive x, oops, wrong color, positive x and negative y, and my theta at fourth quadrant is between 270, I'm dyslexic today, 270 and 360, okay? And then this is my beta 3, this is my beta 2, and this is my beta 4, right? And most likely the reference angle is going to be negative. Alright? So it's good to know these. I mean, should be a review for all of you, so I'm just letting you know that we'll be using this very often. Okay? Now, I haven't even come this close to my third period class because we had pretty much internet issue. So I will stop my lecture here today,